And welcome to week 5 of our exam countdown. So as always, our full members, you're going to have access to loads of material on the TheMathsTutor.ie website. And you will have seen that this week we're going to look in a little bit more detail at logs and indices. As always, for our non-members, I'm going to point you towards some free resources in the chat. So I've linked 2 videos there in the chat for this week. The first one is using logs to solve equations. And the second one there is just an example of an exam question, the solution to a 2016 paper 1 exam question. So hopefully you find those of some use. So let's get straight in. What are logs and what are indices? Okay, well, I'm going to start with indices to start with. And indices is just a plural of index. And an index, another word for an index, is just a power, or sometimes it's known as an exponent. So basically, if you had something like this question, 5 to the power of x is equal to 125. That's what we call an index equation. So it's an equation with an index or a power in it. And x is the variable in the question, and that happens to be in the power or in the index. So logs and indices, they're basically just operators, and they're exact opposite operators of each other. So just like plus or addition and subtraction, they're exact opposite operators of each other. Multiplication and division, they're exact opposite operators of each other. So where do we use them? So I'm going to stick with that question, that equation, 5 to the power of x equals 125. And as I mentioned, for our non-members, there's a really useful video, a link to a really useful video in the chat that'll go through this in a little bit more detail. Okay, so 5 to the power of x equals 125, and my question is, what is x? So have a look, it's up there in the power. Most of you will be able to tell me straight off the top of your head that x is 3. But if you weren't sure, so if x was a decimal or if x was a fraction, how would you do it? So you will see I've just added in a screenshot from the log tables here. So this is page 25. On the left-hand side, we have our laws of logs. And in the middle and on the right-hand side, we have our laws of indices, which we will be looking at in more detail in an exam question in a little bit. I'm just going to draw your attention to this on the top right, first of all. So that's a really handy tool that helps us to change from logs to indices and vice versa. And I'm just going to give you a nice handy trick to help you do that with a little bit more ease, hopefully. Okay, going back to this example on the right-hand side, I'm going to always draw in these anti-clockwise arrows. So I'm starting at the left, working towards the right, because that's the way I read, and then I'm working my way back around the circle. So I'm going anti-clockwise every time. So if I wanted to change this from an index equation to a log equation, I write down my log. I start at the left-hand side, so I start over here as if I'm reading, and that becomes my base number. So it's log base 5, and I work my way around following my anti-clockwise arrows. So it's log base 5 of 125, and again I work my way around using my anti-clockwise arrows. Log base 5 of 125 equals x. And if you weren't sure what the answer was at the start, well, all you have to do is throw that straight into the calculator, and the calculator will tell you that it's x equals 3. So notice what we were looking for here was in the power, so that's why we needed to change to logs. What about if it's vice versa? So if we're changing from a log equation back to an index equation. So for example, I'm going to use this one. We have log to the base 2. This time I'm going to put my x in there, equals 3. So this time, because logs doesn't work, sorry about that, we're going to try change it to indices. So we can use our laws of logs. So this one over here tells us how to change, or we can use our anti-clockwise arrows, which I find really, really useful. So we're going to draw those in again. This time we're changing back to indices. So that tells me, again, starting at the left-hand side, we're going to work our way around following those anti-clockwise arrows. So it becomes 2 to the power of 3 equals x. I'm following around this direction my anti-clockwise arrows. So that tells me, again, this side can just go straight into the calculator. So that just tells me that therefore x is equal to 2 to the power 3, which is just 8. So that's all logs do. Logs basically just tell us, so the base number is your main number, and it's basically, they're just asking us, what number do I get when I raise 2 to the power of 3? Okay, or if we go back to this question up here, this one is basically saying to us, what number do I raise 5 to the power of to get 125? Okay, logs and indices, exact opposites of each other. And like I said, there's a video linked in the chat there just to go through the basics of logs, I suppose, and the basics of exponential equations or index equations linked in the chat. Okay, so just a little note for you for when you use logs. A big hint, you're going to use logs if what you're looking for, so that's the variable in the question, if that's given in the power. Okay, so you're going to use logs if what you're looking for appears in the power. Apologies. So if what you're looking for is in the power, and that's going to be a really useful hint as you go through exam questions to remember. If what you're looking for is in the power, straight away you need to think about logs. Okay, so let's get on to having a look at a couple of questions then. So we're going to start with 2020. And it's paper 1 and it's question 9. So we're just going to be looking at the first part A, parts 1 and 2 of this question. So we'll have a read of the question. We'll highlight any important parts. The number of bacteria in the early stages of a growing colony can be approximated using this function. So I'm just going to highlight that there because that's the function we'll use throughout the question. And this down here is really important as well. Small t is time measured in hours since the colony started to grow, and capital N is the number of bacteria in the colony at any time t. Often people get really confused by this notation here. That's just my function notation where n is my function and t is basically just my variable. So it's not n times t, it's just telling me that n is my function and whatever's in the brackets, that's just your variable in the question. So in this case, your variable, as you can see, it's up here in the power, your variable is t. So the question is asking me, find the number of bacteria. So we've just highlighted that, number of bacteria, that's our capital N, in the colony after that many hours. So that's my time or my small t. And very important for the end of the question, give your answer to the nearest whole number. So that's going to be important as we get down through the question. Okay, so let's make a start on it. We're going to start by just writing out our formula as we're given in the question, e to the power of 0.065 t. So 450 times e. E is just that naturally occurring number. There's a button for that on your calculator. E to the power of 0.065 t. And they're telling us that t is 4.5 hours. So that means that I'm taking my function n, and everywhere I see a t, notice what I've done. I've replaced it with a 4.5. So I'm going to do that the whole way across. 450 e to the power of 0.065, and t just gets replaced with a 4.5. And this side, the right hand side, that can just go straight into your calculator. And remember, E is just the button at the bottom row of your calculator. So what you should be getting when you sub that in is 602.89. Okay, so I've just written 2 decimal places because I know that I'm going to be rounding it up. That's what it's asking me to do up here. And for the nearest whole number, I look at the first digit after the decimal place. Because it's an 8, I round to 603. So I round 602.89 to 603. And again, it's 603 bacteria. So that's quite important at the end. Rounding is usually a mark at the end of every question. So if that part 1 was worth 5 marks, you have, up as far as this point, you've gotten 4 marks. And to get you're rounding correct, that's where the extra mark comes from. Okay, so it doesn't sound like a lot, but it's a lot as we go through the question. Second part, find the time in hours. Okay, so I'm going to stop there. T is what I'm looking for. T is my question mark, if you like. That it takes the colony to grow to 790 bacteria. So that's my number of bacteria, which is N. And again, we'll remind ourselves that at the end, we're giving our answer correct to 1 decimal place. Not a bad idea to just highlight that to remind yourself in the question. Okay, so we're going to just start with our formula again. N of T is 450 e to the power of 0.065 T. This time, what we know is that N is 790. So I'm going to replace my N with 790, and I'm just going to flip around the way the equation is written. So that's 450 e to the 0.065 T. That's going to be equal to N, which we know is 790. So have a look. Look at what we're looking for. We're looking for T. T was my question mark. It's up there in the power. So straight away we know that we need to use logs. So let's just remind ourselves what it tells us in the log tables over at that top right hand side of page 21. It tells us that if we have an index equation just like that, we can use our anti-clockwise arrows to change that back to logs. So that's going to be log to the base A of y equals x. And these two are equivalent. One is just index and one is in logs. They're opposites of each other. But notice up here, it's just a number to a power equals another number. So we have to tidy up this equation first. That 450 is basically in the way. So what we're going to do is we're going to divide both sides by 450. And that will give me e to the power of 0.065 t on the left equals 790 divided by 450. So that's e to the 0.065 t. And when you divide 790 by 450, you'll get 79 over 45. And I've just left it in fraction form. So now we're back to a question very, very similar to this one. We have a number to a power equals another number on the right hand side. So straight away, what I'm looking for is in the power. So I'm using my logs. I'm going to draw in my anti-clockwise arrows, just like that. And that should tell me that we have log. I'm starting at the left, log to the base E, following my arrows, 79 over 45 equals 0.065 t. So I've changed from an index equation to logs in order to solve that index equation. On the left hand side, this can go straight into the calculator. And you might be thinking to yourself, well, log to the base E, that's just ln. That's just our natural log, if you like. So you can either type it in as log to the base E, or you can type it in as ln of 79 over 45. Either way is absolutely perfect. And what that's going to give you, so log of 79 over 45, natural log, that's going to give you 0.562785. And I've just written out a couple of decimal places equals our 0.065 t. So that was on the right hand side. So all that's left to get the t in its own, the 0.065 is in the way, so we're going to divide both sides by 0.065. So that's going to give you 0.562785 divided by 0.065, and that should tell you what t is. Okay, so I think to 1 decimal place, that should be working out as 8.7, and its time, which we're told is given in hours. Okay, so that's just us using our law of logs, or our rule for logs, to change from an index equation, which we had here, into a log equation, which we had down here, because they're exact opposite operators of each other. Okay, so next question we're going to have a look at very quickly, and this will give us a much better idea and a much better insight into our laws of logs from page 21 of our log tables. This is 2016, it's paper 1, and it's question 4, part B. So, given log to the base a of 2 is p, log to the base a of 3 is q, and a is a positive number. Write each of the following in terms of p and q. So basically it wants us to change, in part 1 and 2, it wants us to change everything into p and q. In other words, everything into a log to the base a of 2, which we can replace with p, and a log to the base a of 3, which we can replace with a q. So, starting, we have log to the base a of 8 over 3. And straight away, you should be zoned in on this law of logs, your second law of logs. Why? Well, because it has a fraction in it. And it tells me that if I have a fraction, I change it to 2 logs subtracted. So that's exactly what I'm going to do in the first part here. I'm going to change this to log to the base a of 8 minus log to the base a of 3. Why? Because the second law told me that that's absolutely fine to do. Next, so you'll notice that this one is absolutely perfect. We don't need to do anything more with that because that's just q. But our log to the base a of 8, that's a little bit of a problem. We need somehow to change that big number to a 2. So we'll remind ourselves, well, 8 is just 2 to the power of 3. So what have I done there? Well, all I've done is I've replaced that 8 with a 2 cubed, because that's what 8 is. And then we're going to zone in on this really important law, this third law here, which tells us that if we have a power up here, all we need to do is move it down to the front. So move it down to the front to multiply. And that's absolutely fine to do. Nothing else changes. So that's exactly what we're going to do here. We're going to move that 3 down in front. And we'll just remember that we have a minus log of the base to the base a of 3. And we're going to move this 3 down in front. So that becomes 3 times log to the base a of 2 minus log to the base a of 3. And look what you've gotten then. Log to the base a of 2 is just p. Log to the base a of 3 is just q. So your answer is 3 times p minus r q. And have we answered the question? Well, we've written it in terms of p and q, so we're good. Your second one then, so again, going back and just going to get rid of these marks here so that we can see clearly again which laws of logs that we are using. Again, straight away, I see a fraction in the question, so I should be zoning in on this second law of logs, which tells me that I just subtract my 2 logs. So we're getting log base a of 9a squared minus log base a of 16. I've used law number 2 to change my fraction 9a squared over 16 into 2 logs subtracted from each other. Okay, have a look at 16. 16, again, we're trying to remember change this big number to a 2 or to a 3. So nice and easy, we're going to change 16. 16 is just 2 to the power of 4. And you'll notice here on the left, we have a 9 times an a squared. So that's just like my first law, where we have an x times a y. We have a product, in other words. So we're going to use this first law of indices to write that as log to the base a of 9 plus log to the base a of a squared, because that's what the first law tells us to do. It tells us to add our 2 logs together. Log to the base a of 9, you've probably guessed it. We're going to change 9 into just 3 squared. And every time I see a little power here, I'm going to do the same over here. All we're doing is we're moving it down in front of the log. So that's going to become plus, the 2 comes down in front, log to the base a of a, minus, the 4 comes down in front, log to the base a of 2. So this is actually perfect because that's just our p. And all we have to do here is we have to move that 2 down in front again. So it becomes 2 times log to the base a of 3, and we know log to the base a of 3 is just q, plus 2 times log to the base a of a minus 4 times log to the base a of 2. So this is absolutely perfect. That's just going to be a q. This is perfect. That's just going to be a p. And this in the middle is also perfect. We're just going to take it to the side here. If we had log to the base 5 of 5, if you throw that into your calculator, you should get 1. If you had log to the base 10 of 10, throw it into your calculator, you should get 1. Because basically all this question is asking us is, what number do I raise 5 to the power of to get 5? What number do I raise 10 to the power of to get 10? Obviously your answer is 1. So if you have log, base number and your main number is the same, it's always going to be 1. So over here, that's just going to work out to be 1. So my answer should be 2 times, well, log to base a of 3 is just q. That's just going to give me 2 times 1 minus 4, and that log to the base a of 2 is p. So that's 2q plus 2 minus 4p. Have we answered the question? Well, the question asked us to give our answer in terms of q and p, and that's exactly what we've done. We just have a constant of 2 in there as well. Okay, and a very, very similar question from the 2014 sample paper 1, and it's question 2 part B, is this one. So very, very similar to that one from 2016 that we've just had a look at. We're told that p is equal to log to the base c of x, and it's asking us to express this in terms of p. Okay, so our aim really is to try get everything back to something similar to that so that we can then replace it with a p. So let's just write out exactly what we have. We have log base c of root x, and we have log base c of c times x. So the first thing I'm going to do is I'm going to use my laws of indices, first of all, to change that square root of x to x to the power of a half. So that's going to be log to the base c of x to the power of a half. So square root is always to the power of a half. And I'm going to just very quickly have a look at this. So I have a product, c times x. So I'm going to go back to my first law of logs here. Okay, so that tells me that we have log base c of c plus log base c of x. So the first law tells me to add those two logs together. Remind ourselves that third law of logs, very, very popular law. We bring that power down in front. So that's going to be a half log to the base c of x. That's going to be log to the base c of c, so we'll come back to that in a second, and we're going to leave that as log to the base c of x. So the good news is we've changed everything pretty much into something similar to this. So half stays as a half. Log to the base c of x is p. Log to the base c of c, we came across that in the previous question. That's just 1. And log to the base c of x is just p. So what we have is a half p. So a half p plus 1 plus p. So if I add like terms together, that's just going to give me 1.5p, or 3 over 2p, plus 1. And as the question required, it wanted us to give our answer in terms of p. So it's 3 over 2p, and we have a constant of 1 at the very end there. Okay, so hopefully that was of some use to you. We're just going to very quickly go back to the top and just do a very quick recap on exactly what we did today. So I suppose the main thing is what we've done over here at the right hand side. You've loads of colour there, hopefully to help you. And that's changing from logs to indices and telling you exactly how to do it. So hopefully you find these anti-clockwise arrows. Hopefully you find those very, very useful for changing from logs to indices. And basically there's my anti-clockwise arrows, and it tells me it's a to the power of x equals y. So that's what we have over here at the left hand side. And this point here, I suppose, should be quite useful to you. That's when we use logs. So the only time we use logs is if what we're looking for is in the power. Okay, so you've 3 questions to have a look back over there in your own good time, and make sure you familiarise yourself with the laws of logs. Those are all on page 21 of your log tables. Okay, so as I said, our Full members, make sure that you are clicking into the exam countdown, and you've loads and loads of material there to get you through this week's topic. And for our non-members, you have your 2 free videos in the chat that will hopefully explain things a little bit further for you. Okay, so looking forward to you joining us next week again. Thanks a million for tuning in.